Hello everyone and welcome back to Sketchbook Biology. So yesterday I was watching so many TikTok reels of the Murray Show as compilations on YouTube because that's what adults do. For those who don't know, the Murray Show is a tabloid talk show originally hosted by Murray Povich, and this show often featured paternity tests. That segment became famous because sometimes the paternity test will be negative and Murray will yell, "You are not the father!" And some soon-to-be stepfather will even do a little dance, as the partner struggles with being outed on national television. The funniest of them is when you as a viewer can so very easily tell that the child is not related to the dad. But the couple still come on this show. I have to believe that some of this is scripted. Anyway, in the wild, it's really not that easy, and appearances alone cannot be trusted, especially if your child spends its first few days on Earth inside an egg. Brood parasitism is a very sneaky reproductive strategy used by some birds and a few other animals, where instead of being responsible parents and raising their own chicks, these parasites sneak into and lay their eggs in the nests of other bird species. The unsuspecting host parents end up incubating and feeding the parasites' chicks, often at the expense of their own real kids. Cuckoo birds are infamous perpetrators of this crime. They have near perfected their strategy. Their eggs look almost identical to those of their target hosts, who find it very hard to spot the fake. But that's not all of it. Their chicks usually hatch earlier than their nestmates. This gives them a head start in badgering the host parents for food. And unsurprisingly, just like its real parents, the cuckoo chicks are also not very nice and will happily shove the other chicks or eggs out of the nest entirely. For a while, scientists wondered how cuckoos even manage to hatch so quickly. Turns out the cuckoo moms start incubating the egg even before it is laid. So the baby criminal is developing while it is still inside the criminal mothership. The eggs also have thicker shells, which researchers have suggested may help with retaining more heat, speeding up development, or just to protect the egg if the host parent detects the trickery and pecks or shoves the egg out of the nest. That last part is also very cool because the hosts are also very clever. And just as the cuckoos are finding new ways to avoid paying child support, the host birds are also developing their own ways of dealing with this nuisance. And one host bird species that has cooked up something really special is the superb Fairy-Wren. This very cute little bird is found across the southeastern parts of Australia, including Tasmania and nearby islands. The males in the breeding season are very recognizable. They've got this beautiful mix of electric, almost baby blue and black plumage that shines in the sunlight. Outside the breeding season though, they blend right in with the females and the juveniles, which are more modest with their brown and grey feathers. The Fairy-Wrens also have a fairly complex social life. They're socially monogamous but sexually promiscuous. They already have a hard time figuring out who the father is. The cuckoos just complicate the situation even further. But the superb Fairy-Wrens are fairly good at detecting imposters. Even if they miss the weirdly large egg in the nest and the cuckoo chick manages to hatch, if that chick doesn't sound like a baby Fairy-Wren, that baby is getting taken out. Or sadly, the Fairy-Wrens might just abandon the nest altogether. The cuckoo chick and their original eggs and all. But there is a more skilled cuckoo bird in this regard. The Horsfield bronze-cuckoo is far more successful at fooling the Fairy-Wrens, because their chicks instinctively know how to mimic the begging calls of a Fairy-Wren chick. And if the Fairy-Wrens are fooled, they will feed their strange large baby for a while before they realize what's happened. This is such a problem that Fairy-Wrens will abandon their nests just because they heard a bronze cuckoo in the neighborhood. So, How do you suss out a baby imposter when they look like and sound like one of your own kids? And that is what a team of scientists from the Flinders University in Australia, University of New York, and the Konrad Lorenz Institute of Ethology in Austria decided to investigate. Between 2007 and 2011, over 4 breeding seasons, these researchers monitored 138 superb fairy-wren nests at study sites in the Newland Head Conservation Park, Scott Creek Conservation Park, Cleland Wildlife Sanctuary, and Flinders Chase National Park on Kangaroo Island. Now, only 6 out of the 138 nests showed signs of brood parasitism, but very interestingly, the cuckoo chicks were abandoned once they were alone in the nest and began calling. So what's happening here? The fairy-wrens had somehow realized that the chick in their nest is not their real baby, even though at some point they sounded like one. To better understand how the wrens and the cuckoos communicate, researchers recorded the bird sounds using microphones hidden just below the nests. They captured everything from the female's incubation calls, which were recorded about 10 to 12 days into the incubation, to the begging calls of the cuckoo chicks around 3 to 4 days old. These recordings were then analyzed using acoustic software to create spectrograms. Spectrograms are like these visual maps of sound that show how frequency changes over time. The team then used a statistical technique called spectrographic cross-correlation to measure how closely one call matched another. The output of this technique is basically a table showing how close or different each call is from every other call. The researchers then took that table and did a principal coordinates analysis, which is another statistical method used to visualize and interpret how similar or different these bird calls really were. To see whether the chicks learn the calls of their parent or inherit them, the researchers swapped 22 whole clutches of eggs between different nests early in incubation. Out of these, only 8 nests survived long enough for spectrographic and statistical analysis, but by comparing the calls of the biological chicks, the fostered imposters, and their moms, they could tell if the chicks copied their foster mother's incubation calls. They also ran playback experiments to test whether adult wrens could tell the difference between their own chicks' begging calls and those of the strangers or the cuckoo chicks. Speakers were placed under the nests and the researchers played short audio clips of begging calls while video recording the adult responses. Now, you're probably piecing together what the researchers were getting at. So let's take a look at the results. First, the researchers found that while the eggs were being incubated, the fairy-wren moms made rapid, high-pitched trills lasting about 1.8 seconds and containing around 19 individual sound elements. And they made this incubation call a lot, about 16 times per hour, but only in the last few days before hatching. The moment the eggs hatched, the calling stopped. Now remember the egg swapping experiment where the researchers compared the begging calls of the chicks with the incubation calls of both their biological and foster mothers? Well, the chicks' begging calls were more similar to their foster mother's call than their genetic biological mothers. The more often a foster mother made incubation calls, the stronger this resemblance was. These chicks were picking up the password from their foster mom from inside the egg. But what about the cuckoo chicks? They heard the incubation calls too. But turns out the cuckoos had very low call similarity to their respective fairy-wren mom's incubation call. But why? Well, it's all about timing. Female wrens only start making the incubation calls about 5 days before the eggs hatch. Fairy-wren embryos hear this for several days, but the cuckoo embryos hatch earlier, remember? They hatch early and proceed to roll the other eggs out of the nest. I mean, that alone should have given it away. Anyway, the cuckoo embryos only get about 2 days of exposure to the host's incubation calls, giving them much less time to learn this password. And when the adult wrens heard unfamiliar wren chicks or cuckoo chicks, they became very suspicious. They spent more time scanning for predators, fed the chicks less often, and made more alarm calls. This shows that both parents recognized and reacted to vocal mismatches in the nest. And pretty soon, they figure out if they are the victims of a cuckoo bird. And if that turns out to be the unfortunate case, they'll leave the imposter to its own devices in the empty nest. The pair of fairy-wrens will fly off to start again. And that is where we will leave these clever little birds and their relatively gigantic problem. A special thank you to all the scientists, grad students, undergrads, technicians, and anyone else that spent long hours spying on birds to study and publish this beautiful piece of science. And as always, thank you for hanging out. If today is your birthday, I wish you the happiest day with your real family. And if you're feeling like you've been victimized by a bird, me too. I frequently get harassed by seagulls in parking lots. But if you're just out there planning to lay an egg in someone else's nest, don't do that. Get help. And while you're at it, please like and subscribe. I'll see you guys soon.